Before wheel alignment angles can actually be measured or eventually adjusted, certain checks should be made to the components of the steering and suspension systems. The order of the checks in this program will suit most vehicles. However, manufacturer's recommendations should be followed. The weight of the vehicle must remain on the road wheels while checking the following: the steering wheel retaining nut, the universal joints, steering box mounting bolts, steering box adjustment, pitman arm, idler arm, and tie rod ends. Check for looseness of steering components by having someone move the steering wheel from side to side while the steering components are observed. Excessive movement may be due to the steering wheel retaining nut being loose, the universal joint may be loose or worn, the steering box may be loose at its mountings. If a rack and pinion steering is used, side movement may be present. Excessive movement of this shaft on manual steering boxes may indicate steering box wear or incorrect adjustment. If the pitman arm is loose on the shaft, it could be due to wear on the tapered splines or a loose nut. Up and down movement of the idler arm indicates worn bushes. Movement in the tie rod ends may indicate wear in the joint or looseness of the retaining nut. Initially, the tie rods need to be checked for bends. For the following pre-wheel alignment checks, the vehicle load needs to be removed from the suspension. With a suspension that uses coil springs between the frame and the upper control arm, or McPherson strut, the vehicle must be supported under the cross member or chassis. If a coil spring or torsion bar is used between the frame and lower control arm, the vehicle should be supported under the lower control arm as close to the wheel as possible. In order to check the wheel bearings, grip the tyre, top and bottom, and check for excessive looseness. Kingpin wear can be detected in a similar manner to wheel bearing looseness. Care must be taken not to confuse the two. On vehicles fitted with ball joint suspensions, the amount of vertical and lateral movement detected must be checked against the manufacturer's specifications. It's necessary to use a dial indicator to determine movement accurately. With the suspension unloaded, use a bar to lever between the upper and lower arm and the cross member to ascertain any wear. Use an indicator to check each front rim and tyre assembly for lateral runout, making sure the rim is not damaged and the tyre is seated correctly. Mark the point of maximum runout on the tyre side wall. Shock absorbers must be checked for condition and correct operation. With the wheels on the ground, bounce each corner to gain an indication of the shock absorber's effectiveness. Excessive up and down movement indicates a weak shock absorber. An effective shock absorber allows minimal up and down movement. When checking the condition of the shock absorber, check for oil leaks and the condition of the mountings. Tyre wear should be even across the entire tread. Any uneven wear should be investigated. Some wear patterns could indicate wheel alignment faults. The two most common types are sawtooth wear caused by excessive toe in or toe out, excessive tread wear on one side caused by incorrect camber. Other wear patterns could be caused by underinflation, overinflation, or faulty shock absorbers. Tyre pressure must be correct, as the height of the vehicle will affect alignment readings. Suspension height of a vehicle is measured at points established by the vehicle manufacturer. This may be the distance between the rebound rubber and the suspension, or alternating the difference in height between 2 points on the vehicle to the ground. Prior to these measurements being taken, ensure that the floor is level, tyres are inflated correctly, the vehicle is at curb weight. Factors that can affect the vehicle height may be weak or broken springs, or an excessive load in the rear of the vehicle, which must be removed. The purpose of the rear axle alignment check is to ensure that the rear wheels follow the front wheels, parallel and relative to the centre line of the vehicle. Incorrect tracking could be due to misalignment of the chassis or frame, rear axle housing, or front suspension. One method of checking rear wheel alignment is to position a length of string around all 4 wheels at axle height. With the front wheels in the straight ahead position, measure any dimensions between the string and the front tyres. These dimensions must be equal. The pre-wheel alignment checks presented in this program have included the universal joint, steering box, steering wheel retaining nut, pitman arm, idler arm, tie rod and tie rod ends, wheel bearings, kingpins, ball joints, control arm pivots, tyre and wheel run-out, shock absorbers, tyre wear, tyre pressure, suspension height, rear axle alignment.